Inside an atomic bomb, atoms of uranium or plutonium split apart.
It releases the energy that held the atom together, and it's that energy that constitutes the explosive force.
Barry Bleckman co-founded the Stimson Center, a Washington research institute. He says uranium splits when it's hit by a stray piece of an atom called a neutron. But uranium comes in two main forms, or isotopes, U-235 and U-238, which is slightly heavier.
Only the U-235 will provide the explosive potential. Natural uranium, the uranium you get out of the ground, is less than 1% U-235.
So the uranium has to be purified or enriched. That's where the centrifuges come in, says former nuclear negotiator Robert Einhorn at the Brookings Institution.
First take uranium in the form of a gas, feed it into the centrifuges, spin them very quickly, and different isotopes of uranium separate out according to their weight.
But they only separate a little. So the slightly enriched uranium goes into another centrifuge to separate a little more, and then another and another. How many times depends on what it's for.
If you enrich it to around 3 or 4%, you can use that to provide fuel for a nuclear power reactor. But if you enrich it up to about 90%, then you could use it to build a nuclear bomb.
Iran has also built a nuclear reactor that can run on natural instead of enriched uranium. Experts worry because this kind of plant, called a heavy water reactor, can turn uranium into the other bomb material, plutonium. Unlike U-235, which splits when a neutron hits it, U-238, the kind that makes up most natural uranium, absorbs the neutron and turns it into plutonium.
When you fuel a reactor of this type with natural uranium, it produces a significant quantity of plutonium in the spent fuel. Also of concern was that this is the kind of reactor that a number of other countries that are now nuclear armed use to begin their nuclear weapons program.
This heavy water reactor can also produce chemicals used to treat cancer with radiation. With a few changes, it can still make those chemicals, but produce much less plutonium. Negotiators are working on ways to make those changes, part of a much larger deal on Iran's nuclear program. The deal, if agreed to, would delay Iran's ability to build a bomb by at least a year. That would give the world time to react. Three of the big factors:
You have to get rid of the stockpile of partially enriched uranium. 2, you have to limit the number of centrifuges. And 3, you want to make sure they don't develop more advanced centrifuges, because the ones they have working now are the Model T version. It's very slow.
Faster centrifuges would mean less time to develop a bomb, and more for the world to worry about. Steve Baragona, VOA News, Washington.